Question 5. Statics of particles. A box of mass 2 kilograms is held in equilibrium on a rough inclined plane by a rope. We can add the weight of the mass, that would be 2g, and we can also add in the normal reaction of the weight with the plane, which will be r, and we can show the angle of 30 degrees between the weight and the direction of the normal reaction. There will be a tension T in the rope, and this is inclined to the plane at an angle of alpha, where tan alpha equals 3/4. We draw a triangle, it's 3, 4, 5 right angle triangle. From this we can read off the sine and cosine of alpha. The coefficient of friction between the box and the inclined plane is 1/3, and we're told the box is on the point of slipping up the plane, which means that the friction will act down the plane and will equal mu times the reaction R. We're asked to find the tension in the rope. Resolving forces along the plane, we can see that the component of the weight, 2g sine theta, will equal the tension T cos alpha minus the friction. Into this we substitute a half for sine 30, we substitute 4/5 for cos alpha, and we substitute 1/3 r for f. Now resolving perpendicular to the plane, 2g cos 30 is the component of the weight perpendicular to the plane, and this will equal t sine alpha plus the reaction r. We substitute cos 30 as √3/2, we substitute 3/5 for sine alpha, and we get a second equation. So now we have two equations in t and r. We can solve them simultaneously. So let's multiply our first equation through by 3, and that gives us 3g equals 12/5 t minus r. We add these two equations to eliminate r, and that gives us 3t, that's 12 plus 3/5 is 15/5, which is 3, equals √3 plus 3g. And so t equals 1 plus 1 over √3g, that gives us 15.47 newtons.